I've been in security a while, and I've seen various kind of drivers for doing security things and various kind of
Mm.
measures of security success. So there are some kind of, I would consider them to be almost like security syndromes that we try to avoid.
Hello there, and welcome to the Modern Security Podcast. Today, I'm thrilled to be speaking with Jamie Finnigan, the Director of Product Security at HashiCorp, which you probably know from Vault, Terraform, and many other cool tools. So today, I'm excited to get into a number of topics, such as how HashiCorp built the product security org up from scratch, how they determine what to work on and what to prioritize, how HashiCorp's product security team thinks about developer experience, or DevX, given that they work at a developer tools company. And finally, we're going to dive into two specific examples of how they've invested in secure guardrails in order to scale HashiCorp's security posture and eliminate classes of vulnerabilities. But before we get into it, a little bit about me. Hey, my name is Clint Gibler. I'm the head of security research at Semgrep. We have an open source tool called Semgrep that's great for scanning source code. We also have a premium engine and rules. We have a SCA product that looks for vulnerable dependencies, and we just launched a secrets product that will help you find all the hard-coded secrets in your code. I also run TLDRSec, a cybersecurity newsletter that sends you the latest and greatest tools, blog posts, and talks for free every week in your inbox. But most importantly, I'm here with Jamie Finnigan. So welcome, and tell us a little bit about yourselves.
Yeah, hey Clint. Hey everybody. Nice to finally be here, Clint. I, for one, definitely appreciate the work you do for the industry at large with TLDRSec, and am also a fan of Semgrep. So nice to be able to connect and chat.
Thank you so much.
Yeah, like Clint said, I'm currently running the product security team at HashiCorp. If I go back, I guess I've been doing the security technology thing for over 20 years now. Started my career in New Zealand working for, well, my first tech job was on the help desk at a startup internet provider where we would spend our time troubleshooting Windows 95 dial-up networking settings over the phone. So I can't quite walk you through a control panel dial-up networking setup anymore without looking at a screen, but that used to be a skill set of mine. From working in tech in general, I kind of was help desk, I did Linux sysadmin, and then from there moved into security. That was more or less a mistake where I was reading the newspaper one day and was looking at the job listings, and Deloitte was advertising for entry-level security consultants they were looking to hire. So I spent 7 years at Deloitte doing mostly penetration testing, vulnerability assessment type of work, with the occasional IT general controls or other kind of risk assessment type project when utilization figures needed to be met. I spent about 4 years in New Zealand working for Deloitte there, and then you hit your early 20s, every Kiwi realizes New Zealand is small and they go off on their big OE for a few years. So I got Deloitte to transfer me to the Bay Area, where I found out that America is a lot bigger than New Zealand. And yeah, I'm still here in America. The Bay Area was a short stint, but I'm now up in North Bend, Washington, just outside of Seattle. And yeah, I've been here for a number of years now. Since Deloitte, I kind of hopped through a number of different employers. I spent a short amount of time at IOActive, spent some time at T-Mobile. I was at Zynga protecting everybody's Farmville cache for a while. From Zynga, I spent time at HP working on open source cloud security. From there, I went to a Seattle startup that was doing scientific wellness. I was basically their security team member for a few years. And then, yeah, from there, went to HashiCorp, where I'm now kind of 4.5 years in on this, quite a journey of helping kind of grow and secure this company and the set of products we have. So, yeah, that's kind of the TLDR on life so far, I guess.
Yeah, thanks for sharing. And I'm really excited to dig more into that journey at HashiCorp. But just to make sure everyone's on the same page before we get into it, can you give people a brief overview of HashiCorp's product suite? Because I bet people have heard of one or two of them, but there's probably at least three or four that the average person may have not heard of.
Yeah, it's funny how every now and then I tell people I work for HashiCorp and they have no idea who we are. But then, oh, Terraform, oh, Vault, yeah, there's some product recognition there that doesn't necessarily tie strictly to the company name. But yeah, HashiCorp, been around a while. Started with Vagrant, was probably the kind of original project that people might be familiar with. Other products, Terraform, which is an infrastructure as code type of a solution. We have Vault, which is a kind of all things secrets and kind of security solution. We have Consul, which does networking, cloud networking and service mesh. We have Nomad, which is, for one of the better descriptor, it's basically like a Kubernetes Lite, really workload orchestration platform. We have Boundary, which does secure remote access, and then we have Waypoint, which is a kind of developer templating, developer workflow platform. So yeah, we've got a range of products all focused around infrastructure, cloud, and developer experience in various ways. One, I guess, interesting thing about those products is we started with open source, we started with community editions. We have self-managed enterprise versions of those products. So we kind of add the enterprise level value adds and then sell those products to customers to run in their own environments. And then we also have cloud delivered versions of many of those products too. So yeah, the threat model that they're working with and the product delivery modes we're working with do make it a fairly interesting environment with a lot of security challenges to address as well.
Yeah, that's interesting because I guess similar to, say, GitHub as another example, you have, GitHub Enterprise on-prem, and then you also have github.com. So you have similar thing. And you also have a number of different products that do very different things, complementary, but meaningfully different. So that is an interesting challenge, I think, from like, how do you secure these things that are not all just like normal web app, but like different web apps that do different web appy things. So yeah, that'll be fun to get into. But before we do, so you've been there about 4.5 years. I believe you said our mutual friend Talha hired you as like the first product security hire, perhaps?
Yeah. So I guess indicative of the job market at the time, perhaps the startup I was working for ran out of funding, sadly, and we were closing up shop. I found out that was happening one day and posted on one of our kind of security Slacks that the community has. And within 10 minutes of posting that I was looking for work, Talha had replied and suggested that we should talk. So yeah, that was a fortuitous and I guess a good demonstrator of, the importance of community and being connected within the security industry here. But yes, Talha had just joined. He was the kind of hired as CSO and tasked with building a security organization that was ready to scale with the company. I was his first hire, and yeah, since then the company's grown a lot. The security organization has grown a lot, and we've gone through a number of inflection points, and continued to do what we need to do to keep up, essentially. So yeah, the product security team, I guess I can tell you a little bit about.
Yeah, I'd love to know a little bit about what's within your purview, maybe how the team has grown over time. If you're comfortable sharing numbers or perhaps percentages of the types of things people work on, I think all that would be, to me, very interesting.
Yeah, sure. I guess the security organization overall essentially is made up of three parts. We have product security, the piece that I look after. We have security engineering, which is more of the infrastructure and operations oriented side of the house, buildings, the building side of the house as well. And then we have a GRC organization too. So kind of three main parts of the security org. My team, product security, very focused on the product themselves. We spend a lot of time looking at the product architectures, the product workflows and the code bases that support all of that. So yeah, we think about security threat models, we think about application security, we think about kind of the underlying cloud infrastructure to some extent. We do internal tooling development. We also do kind of the BISO style consulting as well. So individual engineers in my team are partnering with product lines within HashiCorp, with engineering teams to help design and build secure products. Yeah, that's essentially us. What did I miss in this? Oh, one of the other things we do, vulnerability management. So if there's vulnerabilities in our products, our team is either finding them or receiving reports of them, and we'll take care of kind of the initial triage, validation, and then work with engineering teams on remediation. We draft the security bulletins, help get the fixes out, that kind of, all that, the fun parts of that workflow. So yeah, we've got a range of things we do. And like I said, it's across across the community products, the self-managed products, and the cloud-delivered products. So yeah, there's a fairly broad set of things that we are responsible for here.
Nice. Yeah, thanks for the overview. That is interesting to think about all the different things within your purview. Given that there's all of these different aspects as well as different products, I'm curious how you or the team thinks about determining what should we focus on, what should we invest in, and maybe either before or after that, how do you measure success? Like, we could do this thing, it's going to take maybe a quarter's worth of work. What is our success criteria? How do we know when we've done a good job? Because chatting with friends of mine at a number of different companies, I think these are recurring questions that come up pretty consistently. Like, there's many things we could do. What do we prioritize? And then how do we know if we're successful, or maybe even how successful?
Yeah, great question. I guess one way that we as a product security team talk about our work is, pardon me, we talk about product work, and then we talk about program work. So the distinction there is we have kind of product specific work where we might be spending time specifically on Vault or specifically on Terraform. And then there's the program level or the portfolio wide work. So that's where we're working on tooling or process that applies across all of our products and tries to get that economy of scale by doing one thing and doing it well across all of the products, rather than having to do the same thing 6 times, right? It makes sense to operate that way. So yeah, and this is actually maybe an interesting recent shift for us, where up until recently, the way we were organized was essentially that individuals in the product security team would do a bit of both. Like, you kind of had an area of a specific product you were responsible for, as well as a portfolio or a program level thing that you might have been responsible for too. That worked to a point, but we found as we grew that lines of ownership would get a bit blurry, and it was kind of sometimes difficult to know for any given individual what was their priority at the time. So we recently went through a small reorg where we split into sub-teams, or really teams. They're teams in their own right. That one team is focused on product partnerships, so that's kind of that product-specific focus, the consulting element of it. And then another separate team is focused more on the program level pieces, where they're building tools that are used, building processes. Yeah, that's a relatively recent shift, which is feeling pretty good so far, and I think is giving us the ability to get a little more predictable about how we plan work, how we prioritize it, how we assign ownership, and make sure it actually gets tracked and done. Initially, most of what we did was product focused. That's where it was probably kind of an 80-20 type of a deal, where most of the work being done was focused on specific products. And then kind of 20% time was go do kind of whatever helped push forward the program level things that we wanted to get done. That helped achieve kind of the product specific goals we had, but we were finding that our program level work was suffering. Like, we weren't able to get to a predictable delivery. We were kind of finding some of the strategic things that we wanted to get done to really push security forward was just getting distracted by other things. So we're slowly moving emphasis toward doing more of that program level work. So yeah, I think as we've grown and as the company's matured, that balance is shifting from kind of 80-20 probably to more like a 70-30, 60-40 type of an approach now. And then the recent reorg has let us get a few individuals more like 100% on this program level work. So yeah, it's giving us I think the potential benefits from getting that program level work completed and in place are something that we are really trying to realize now. So yeah.
Nice. That makes sense. In your ideal world, would the breakdown be around 60% product, 40% program level focus? Or there's not
Yeah.
really a right answer. I'm just curious.
Yeah, I think you need both, right? So you want your products
Mm-hmm.
to be secure, and then there's also absolutely benefit to be gained from doing things across the portfolio. So I think 60-40, 50-50, like, yeah, being able to define, to plan and execute in both of those areas is important. So, yeah.
Yeah, that makes a lot of sense to me. So before we sort of dug in, I think you were about to describe a little bit more about how you measure success. And
Yeah.
when we were chatting before this, you talked about considering sort of the overall business success, customer satisfaction, engaging with stakeholders, and more. So yeah, could you share a little bit about how you think about success and the various things the
Yeah.
project team is involved with?
Yeah, absolutely. I guess I'd start by saying, I've been in security a while and I've seen various kind of drivers for doing security things and various kind of
Mm,
measures of security success. So there are some kind of, I would consider them to be almost like security syndromes that we try to avoid. So we really try
mm,
to avoid just kind of the checkbox checking type of security. We try to avoid security theater driven prioritization. We try to avoid kind of silver bullets where you're like, oh, there's one thing, if we just get this done, it's going to solve kind of all of these problems. Generally not true. And shiny object syndrome too is another one that you kind of, sometimes you just got to focus and get the basics done before you move on to whatever the new hot thing is. So yeah, generally, like, it's easy to say, I guess, kind of my rule of thumb, we try to kind of invest pragmatically in the right thing at the right time. Like that's fairly vague. What that actually means is kind of we start with what are the high level company goals. We're looking at things like what's the product roadmap, what's the high
mm,
level intended outcomes for the year. Then we look at security org goals, plans, and from there we look at what the project team needs to get done. Success itself is a fairly complicated measure, I think. I mean, you can go at multiple levels, right? There's like high level business success. There's customer satisfaction. Do they actually like the products and are they able to deploy and use them in a secure way? There's stakeholder engagement. So internal to the company, there's like, do we have a good relationship with our R&D partners? Are we working well with them? I also look at team member happiness. Like I want the people who are working within product security as well as more broadly to be engaged and actually enjoying the work they do. We've got other measures like risk reduction. It's kind of a fairly common security approach. Control testing and coverage is an interesting measure of success to look at.
Yeah, could you go into that in a little bit more detail? I think
Yeah,
I've read some interesting blog posts recently talking about measuring security control performance and just general security coverage over time. So yeah, I'm curious how you think about that.
yeah. So I guess we have a fairly broad portfolio of products that we are responsible for. Um, for us, uh, there's kind of a baseline level of coverage that we aim to achieve across all of our products. And then there's a risk-based or a kind of business priority-based additional level of coverage that, given time and resources, will invest further in to achieve those kind of double down and get additional work done, I guess. So yeah, there's kind of security basics, security hygiene. You got to get the stuff done across all the things, and then there's the additional investment that will depend on that broader set of things I talked about, I guess, in terms of what the business is trying to do, what the product lines are trying to do, where the vulnerabilities are being identified and remediation is needed. So yeah, range of things there. I guess one of
that
the
makes
things
sense.
oh
No, keep going.
yeah, one of the things I do like to look at is thinking about kind of the difference between outputs and outcomes. I think static analysis is maybe a good example there of it's easy to generate a lot of output with your static analysis solution. Or vulnerability scanning too is a good one where you kind of deploy a solution, run it against all the things. So, I mean, there's an argument to be made there that you may have very good coverage with a tool. I can turn on static analysis, enable it across all the repos in our GitHub org, and great, my coverage is good. But that is essentially an output. Like, you run the tool, it generates results, but it's not necessarily like there's no outcome associated with that. The outcome that you'd really want to see is not just run the tool and generate results, but it's triage the results, remove all the false positives, and then go actually remediate the issues to the final outcome of having identified and resolved these security problems with your product, right? So I guess that kind of comes back to coverage and what we're talking about there.
I totally agree. You can, using container scanning, SAST, SCA, DAST, like you can do all the things, but if no one actually fixes the things that are found, it's almost like, why use it in the first place? Obviously not necessarily fix everything that's found. You want to do some sort of prioritization based on criticality, importance to the business, and other things you've been talking about. But I totally agree. I think having good coverage, but the outcome is having risk being reduced via vulnerabilities being fixed. It's kind of like you're reading a bunch of books on fitness, but then you never exercise. It's like, yes, you are gaining knowledge and maybe signals about your environment, but you are not, getting more fit by just like the information alone.
Yeah, we had an interesting discussion this morning actually on our team call where we have the same problem as many security teams do, where you run tools, you have kind of collections of results that you need to go do something about. So kind of really looking for signal from noise, looking to generate outcomes from outputs perhaps. But the interesting thing here was our first step in with this particular tool that we were looking at was to say, okay, we have this long list of issues, supposed issues that have been identified. Let's start by, we're just going to do the criticals. So we looked at the filtered by critical in the tool, and we had a list of approximately 40 rated critical issues that we needed to go follow up on. Guess how many of them were valid findings that we needed to actually go do something about?
Can you say what like vertical of tool? Is it like cloud, container, static analysis? You don't have to name the name of it.
Yeah, this is static analysis.
Okay.
Not necessarily critical. A good static analysis tool.
Did the tool provide signal about not just severity of the finding, but also like confidence?
No, it didn't give us confidence. That's a good question. Though. Good call.
One thing that so obviously I work at a static analysis company, and one thing that I feel like all security tooling ideally should do is provide a couple of factors. So it's like, hey, if we found this thing and it was right, how big a deal is it? So sort of like
Mm.
impact maybe, and then ideally also how confident are you, maybe similarly like low, medium, high or something, that like this is actually a thing.
Mm.
Because when you're building a tool, regardless of the approach, whether it's SaaS, DAST, or otherwise, sometimes you have to make assumptions perhaps about how the code works or the environment or things like that. And sometimes you have an intuition about, well, and also there's trade-offs when you're making a tool, like, do we want to try to find everything, or are we okay missing some things if the things that we do find are more likely to be accurate? And there's obviously trade-offs. Like
Yeah.
sometimes depending on the business and the application, you really want to find everything, and it's okay. You're willing to triage a number of false positives to like really find everything. Whereas in other cases, you're like, well, either we don't have the people, or maybe the application isn't important enough to justify like a huge amount of triage. So depending on the product, maturity of the company, the vertical, maybe
Mm.
the audience, things like that, there's definitely different models. But yeah, so
Yeah.
that's why I asked about
No,
because
that's a great
ideally,
question. Like, it's interesting. I mentioned I worked at HP, and one of the things I got to do there was be involved in starting Bandit, the Python focused static analyzer.
oh, cool.
Um, I think you're friends with Travis McPeak as well.
I am,
He was
yeah.
involved too. Bandit Bandit started life as a Python script on my laptop from one late night hacking exercise, I
Nice.
guess. And then fairly quickly, Travis got involved as well. So confidence was actually one thing that we as a Bandit team chose to build into that relatively early in its life, and it's still there. That concept of have the tool tell you like, does this rule, how much should you rely on this rule to give you a good signal from what it's looking at. Yeah.
Okay, so you said 40 critical issues.
Yeah,
Can
yeah.
you?
Sorry, back to that. None of them were applicable in our context. It was,
Oh no.
a complete wash. So you never know what you're going to get when you do that, though, right? Sometimes you just hit a rule that does make sense in your code base, in your framework, and the security model for your product, and we just keep on kind of going through these tools and fine tuning our usage of them and trying to get that value that is there.
Yeah, I think that's a really good point where pretty much every tool, regardless of the type of vertical, I think does require some customization to the environment to get the maximum amount of
Absolutely.
value. Like,
Yeah.
depending on the technology and the tool, it could require more or less tuning. But I think that at least in no vertical, in no company that I've ever heard of, has that amount of customization been zero. Not just talking about SaaS, but I mean like,
Right.
I don't know, cloud scanning, container scanning. Like every environment's a little bit different.
Network
Every company has
scanning,
different
Dash.
priorities.
Yeah.
So
Yeah.
I mean, ideally, it's a tractable amount of tuning. It's not like you're spending 40 hours a week for like 2 years. Like that's way too much. But I just wanted to, agree with you when you said like, it's not zero.
Right.
Um, Ideally, it's like small and finite.
Yes.
Oh, so of the 40, zero mattered. Was it because of like the broader context about the code that the tool perhaps didn't know, or was it just the checks itself didn't?
There was definitely some of that. So yeah, I think it was around about 20 to 30% of them were the context, or kind of the way that the vulnerable code was being used was, it either mitigated it or just meant that the exposure wasn't there. So yeah, definitely that's a tricky problem to solve with automation, right?
So chatting with a couple of friends leading different product security teams, I think sometimes, exactly as you said, for different repos or different products, you have a set of assumptions about how it works and maybe how it doesn't work. And in an ideal world, you could codify that knowledge such that every security scanning tool that's scanning that application can like ingest that information and include it in sort of its threat model or things like that. So one example might be, I know a number of SAST tools by default say that potentially reading from a file or an environment variable or something like that technically could have user controlled data, so that if that goes to like a shell execing something, that could be dangerous. But in practice, in my experience, so when I was a security consultant at NCC Group, some of my projects were helping companies like tune their SaaS tool and just overall try to build a more effective AppSec program. And in like 99% of the cases, it was like, well, this application is running on a server we control. So if an attacker can like write a file on the server's file system or control the environment variables, like we've got a lot bigger problems than the fact that like they could run a shell command. It's like they're already on the server. Of course they can run a shell command.
Right.
But yeah, I like your point of if we could somehow codify these security assumptions, maybe with LLMs or something. The LLMs look at the code, look at the README, they like write down the security invariants that this repo should have. I'm sure there's at least 10 startups working on this problem right as we speak.
Yeah. One of the things that HashiCorp was already doing when I joined was for each of their products, they had a public, explicitly documented security model of basically the list of things
I like that.
The list of really security commitments or security controls that the product does attempt to enforce versus doesn't. So it gives you like this is what the product's trying to do. These are the things that the security things that we are explicitly not trying to do. What do engineers need in real or close to real time to make good security decisions? And then what do we do outside of engineering workflows in kind of an async fashion that we as a security team can consume and kind of help help drive forward as well. So yeah, the developer experience is huge. We try to build tools and deploy tools in a way that works for engineering. We try to integrate into existing tooling, into existing workflows. I think maybe one good example here is historically, you see security teams that adopt security tooling and then start generating reports. Might be a PDF, might be a CSV, might be whatever it is. And this is kind of this external separate artifact that then is provided to engineering teams to go do what they do with. What we've tried to do at HashiCorp is take the security related information we have to our developers in the tools they're already using. So GitHub is where most of our code lives. We ingest SSRF into GitHub and use that security tab within a GitHub repo to provide security related information to developers. They're not having to go out to an entirely separate web interface or look at a separate report to get that's right there in the browser along with their code. So that's just one example of what we've done. The challenge there again is making sure that it's not just taking the information to the right place, but it's also taking the right amount of actionable and valuable information. Like you don't just want to generate a bunch of noise and kind of push it into PR checks or into developer interfaces. But yeah, we do try to be cautious and take on that initial brunt of the triage ourselves, verify the value of whatever check it is that we're wanting to do, whatever tool we're wanting to run, and make sure it works before we roll it out in that kind of program level, portfolio wide fashion.
Nice. I think you've outlined a number of best practices I've heard across a number of companies. So, providing security signal to developers within the systems and platforms they're already using, such as GitHub, and not making them go to a separate dashboard, and then also initially putting the upfront work in as a security team to make sure that what you're providing is high signal, valuable, and is worth their time and not going to damage the relationship you have with them.
Yeah, exactly.
One thing you mentioned that I was curious to know more about is you talked about thinking of it in two ways. So one is, what is the information you provide developers sort of not quite synchronously, but I mean like real time-ish within the developer workflow, and then also the asynchronous things that maybe the security team is viewing and acting on, and then eventually may reach out to engineers about. So you talked about PR comments as one example of within the developer flow. I was wondering if there's another example or two you could give about both the sort of direct real-time aspect, as well as maybe one or two examples of the sort of asynchronous types of work that the security team does, and then eventually sort of brings it to engineers.
Yeah, absolutely. So we have a range of, I guess, external tools as well as internally developed tools for generally identifying security issues in our products. I said too, there's perhaps actually kind of three areas that I'd call out. So one is the developer day-to-day kind of engineering process. And for that one, PRs are the main place where we're currently looking to inject security feedback. We do that using an internal tool that is essentially an aggregator around, it has a plugin model, so it has a combination of its own kind of custom in-house checks, as well as the ability to essentially shell out and run other security tooling in the context of a PR. What we're doing there is not necessarily running every single check, just trying to keep it to a relatively minimal, quick run, give engineers high risk things that they can action quickly. So that's PR level. Then there's probably the kind of pre-release stage. So we have a release engineering team here who's done a great job of building out a common kind of release pipeline that gets used for pushing all of our products out into their publicly consumable repositories. But at the release stage is when we do similar tooling, different set of tests. We're looking at like, okay, maybe this is where we do some container image scans and do kind of a broader set of tests that need to be done before a product actually goes out the door to be available for use. So that's kind of number two. That also happens real time as the release pipeline is run. So whoever's in charge of running a release for a product will be getting security feedback as that pipeline executes. And then the third piece is the async piece, which is we have kind of nightly, weekly, monthly batch jobs that go and run kind of the broader suite of tests. And then those are mostly consumed by the security team initially, where we would do triage and kind of, that's maybe where a security check might first be deployed. And then as we use it there and learn from it, it might kind of move up into one of those other stages I talked about. So yeah, trying to have a staggered approach, not trying to scan for all the things at every stage, but trying to do kind of, again, kind of the right thing at the right time, which is easier said than done. But yeah, that's the general approach, I guess.
Nice. I like that a lot. So maybe there's a new tool or a new security check. First, you're like, okay, let's run this asynchronously, daily, weekly, monthly. Security person is triaging it, and they're maybe tracking, okay, about 20, 30, 70% of the time it's been right. So at some threshold, maybe we turn this on in the regular PR flow, maybe as like a commenting, maybe not a blocking. I'm curious, do you have a rough percent, or like what sort of metrics do you consider when thinking about promoting a check or a tool from asynchronous security team is looking at it to sort of automatically show it to developers?
We don't have that down to a science yet. I think we will at some point have metrics and kind of a more scientific approach to it. I think for now it's when you run these things in that async mode, it's when you see actual value from it. So to that kind of point we were discussing earlier about running tools and dealing with false positives, kind of are these checks, in the context that they're running in the frameworks they're running in, do they actually provide value? Are they real-time blocking security? Are they preventing security issues from occurring or being introduced or being shipped? Then that's where they get promoted forward, I think. Like I said, not a science yet, something we're working on moving towards, I guess.
Yeah,
I
that
think
makes
maybe
sense.
one of the other angles on this is thinking about like not just where to run it, but what to run as well. So tool
Mm,
selection is an interesting part of the picture. Um, for that, we kind of think about, okay, what is the general risk that we're trying to mitigate? Kind of get away from, hey, this tool looks cool, let's grab it and run it. But it's more, hey, we have this risk that we're trying to prevent. What are the options that we have? Um, in some cases, that might be, hey, we're going to build a small internal check for it. And others, it might be, we're going to kind of look at an existing tool. Maybe there's extensible existing tools we can add a check to, or there's a net new tool we bring in. But really, you're kind of looking at, okay, what's the risk we're trying to mitigate? What are maybe the inputs or integration points? What are the options we have for where we might put this tool in a workflow? Um, then there's like, what is the experience of the tool or the process? Does it take 5 seconds or 5 minutes or 50 minutes to run? Kind of that changes your
mm,
decision as to where it might land. And then, the outputs and outcomes, like what are is the outcome that gives me a higher value type of an outcome? So maybe there you put it further forward in the process, or is it a lower value and then it maybe sits further back in the async scans? So yeah, another kind of easier said than done is, there's that whole concept of shifting left that's become fairly popular. I like to put a
mm,
slight tweak on that of saying, yes, we need to shift left, but we need to shift the right amount of things left and maybe keep some of that stuff back, because you don't want to
mm.
just bog down everything on the left, just keeping, I think there's a measured approach to that we're trying to bring.
Yeah, I think what you've described about being very careful and selective about what is high signal, what is meaningfully mitigating risk, and moving those sort of things earlier, and then things that you have maybe less confidence about or provide some value, but their signal to noise ratio maybe is not quite as much there, and letting that be a little bit more async and later in the process. That makes a lot of sense to me.
Mm,
One thing you mentioned before when we were chatting before this, that sometimes either a tool or a specific check is a firm blocker, like maybe you're blocking the
mm.
PR unless it's addressed, and sometimes you just give warnings. And I was curious if you could provide a little bit more context about when you would do one versus the other, and maybe your thought process more generally when you think of that choice.
Yeah, I think there's a number of different variables that come into that. So we've talked already about kind of noise versus value of output. I think there's other elements too, like engineering culture and capability is a big one. Like if you have
Mm,
a relatively small team of engineers working on a well-known product, they're experienced, they have their security model dialed and they're iterating on this thing. They're a different sort of team to a team that is working on something net new, maybe with more junior engineers, maybe just more pressure to actually go get this thing done quickly and deliver it. There's various
mm,
kind of bigger picture things to think about, I think, there that help kind of decide, how stringently do you enforce or not these security checks that you're running. Um, there's also like appetite for risk. Maybe some products are at different stages to other. Some are in that kind of MVP stage where you're just trying to push and get something out the door. That might run in a less kind of security heavy workflow. And then if you have kind of an established product that is depended upon by a number of customers where there's significantly more risk involved, then that gets a higher level of scrutiny and you do more things there from a security perspective. So I think, what else do we think about?
mm,
Oh, ability to go back and actually fix the thing is important, right? Like if you have a way to detect a security issue, um, but that security is, but it's essentially the ship has sailed type of a problem, right? Like if there's there's some decisions that get made as part of the kind of product development process that once they are made or once something has been implemented, it is difficult to get back out, or it's difficult to go and implement whatever security remediation you need to do. So trying to get checks for that in earlier in the process and kind of help prevent against introducing kind of long-lived issues that are going to be painful to remediate is another part of it too. So yeah, there's various variables, I guess, there that come into it.
Yeah, I like that a lot. The sort of focus on how much work or how big a pain is this going to be to fix in the future. You could imagine, to take maybe a very stretched example, you could say back in the day when people were doing waterfall and only shipping a new thing once a year. Well, yeah, if there's a critical security issue, you better fix that before it's deployed. Whereas if you are deploying new code to a web app 100 times a day, it's not good to have a serious security risk out there. But if you can fix it really quickly and you're already shipping code so quickly, then maybe you don't care. So yeah, I liked what you said. And I'm also imagining maybe making certain architecture choices early could, if there's some insecurities in sort of the architecture that are maybe fundamentally hard to mitigate against in code later, you can imagine trying to fix that early is going to save you a huge amount of time. I thought that was a cool insight you shared. So yeah, so thank you. So moving forward, let's get into two specific examples of secure guardrails, or more broadly, just trying to scale security investment. You talked before about sort of a product focus where you're focused per product, and then sort of program focus. So I think we're maybe shifting more to the program side where you're trying to build the tooling or infrastructures or libraries that are solving classes of vulnerabilities. And you shared two specific examples, and yeah, I thought it would be nice to dive into them. So the first is regarding SSRF, or server-side request forgery, which I was very happy you brought up, because it turns out it's a surprisingly hard problem. And I feel like most people, when they initially think about it, aren't aware of maybe how subtle it is. So maybe before we get into it, we can just riff on a couple of examples of why this is hard, and I can provide a few, and feel free to jump in. So part of this was as a security consultant, watching other companies trying to solve this, and then being like, oh yeah, there's a lot of edge cases here. So in many modern applications, depending on the functionality of the app, you may need to accept arbitrary URLs. So you can't just say, if you're not redirecting to my domain, don't do it. Or if you're not making, don't make an HTTP request unless it's to my domain. But oftentimes you can't do that. So it needs to be arbitrary URLs. And then you might be well, I'll just detect if it's an IP address, because, then someone's maybe trying to hit the metadata service or something like that if you're in a cloud environment. And then you're actually there's 50 different ways to represent IP addresses. And even if you manage to enumerate all of those, you could also say well, someone could do some sort of DNS or binding attack where they provide a link to a server they control, which, initially says, oh yes, this is a normal, URL and IP, nothing to see here. But then there's sort of a time of check, time of talk to, time of check, time of use issue where they then in subsequent requests then resolve to an IP address that's different than sort of the initial one. And there's all sorts of things. I don't know, what are some other things that maybe, I guess, well, why else is this hard?
I think to your initial point, the web used to be a much simpler thing, right? It was just simple hrefs back and forth, and web apps, websites were relatively I guess self-sustaining, perhaps is the right word, independent maybe. But these days you look at the way cloud has evolved, and you look at the way the various solutions that we use have evolved. There is so much more integration between applications than there used to be. You look at and they do that with URLs. You look at single sign-on capabilities. You look at webhooks, you look at all these kind of features that help enable integration between one app and another. And it essentially all involves processing URLs that have various levels of trust associated with them on your own infrastructure. So I think it's an increasing attack surface for sure that you're dealing with.
Definitely. So in anything that is a bit complicated and there's tons of edge cases and you need to have some security expertise in order to not shoot yourself in the foot, I think this is a great domain for the product security team to try to like pave the road a bit and make developers' jobs easier. So let's get into it. Could you share a bit about what you did to address this at HashiCorp?
Essentially, that's putting a proxy in behind the application and then applying an allow list there that as the application makes outbound requests, they pass through the proxy applies a level of filtering to it, and then either allows or denies those web requests from actually making their way out to the systems that they're targeting. So we put the proxy in place and we made it opt-in for a start. So deployed the proxy, had it operating, and then just started for certain types of web requests that the application was making, pushing them out through the proxy. Monitored that, tested it, made sure that we ironed out all the bugs, and then had it as an opt-in capability that engineers could start to use. So we started seeing engineering adoption of this, where they were pushing more of their web requests out through it. As we became comfortable with that, and as we explored exposure of SSRF in general, we decided that we were ready for the next step, which was to go from it being an opt-in proxy that engineering could choose to push traffic through to being a proxy that all outbound traffic was being directed through. So technically, the way we did that was basically monkey patch it into the framework. So this was a Rails app, and we used essentially kind of that Ruby monkey patching magic to force traffic out through this proxy. The nice thing about doing it at that level was that it catches not just the application code itself, but also requests coming from gems and kind of other non-core components of the app. And essentially, you end up with developers have to think less about SSRF than they did. The platform kind of gives them that protection essentially for free, where they know that the traffic's going out through this proxy. They know that the proxy will apply these security controls for them. And as a security team and as an engineering team, we feel good about the end result, which is that we have this established pattern in place that, yes, has some operational overhead, but really helps kind of make that default anti-SSRF control available and enforced, essentially. So that's kind of the story. Anything stand out there, or anything you want to dig into more?
Nice. No, I like it a lot. I really appreciate sort of the overall methodology in terms of first, like, okay, what security signals are we getting? Whether that be pen test tool, bug bounty, whatever. Okay, we got one SSRF reported. Oh, here's like another few. Okay, maybe this is something we want to invest in. So you have some signal in terms of what should you prioritize. Then you think about a couple of different options to solve it. And you're like, okay, maybe proxy pattern. This makes sense. I like that you made it opt-in at the start, so you didn't immediately roll it out everywhere, and then there's some bug that makes you start dropping traffic, and then I don't know, customers start complaining and dev teams don't trust you. You're like, okay, let's maybe work with one or two teams, have them do it just opt-in, and then you're getting signal, you're ironing out kinks, you're fixing bugs. Then what I really liked was sort of the final phase where you're like, okay, this is battle tested. We have high confidence it's going to work. We are going to set it up in a way, not just that it's like totally transparent to developers and like the code they write, but also in the underlying gems and libraries that they use. I assume you're monkey patching like net URI or some like Ruby standard library function that is like used by, I don't know, the developer making HTTP requests as well as like any other gem. So not like maybe monkey patching the high level API, but like actually like the API all the other like code uses so that you
Yeah.
sort of capture everything, which
Yeah.
such a nice, elegant approach. Ruby has a lot of things that can make it difficult to understand what's happening, but I think that that's definitely like a cool superpower of the type of things you can do when you have a runtime like that.
Yes, the joys of dynamic versus more static environment languages and frameworks, right? uh,
Yeah, for sure. Well,
um,
yeah, I think that that's super cool. And so you said that developers basically get it for free. Is that just like if they're using one of the repos that already has maybe this gem or monkey patch in, they don't have to think about it? And then do you have like a template repo where if people fork that, then they automatically get it as well? Or like
yeah,
how do you have this protection built in for like new future things, not just the things you've already outfitted?
yeah. So for this one, it's essentially a monolith of sorts. So it really does kind of do it once, and they inherit it as they continue to work on the app that this code base is part of. So yeah, it's we haven't had to go to that templating method you described, but that would be how we would do it in future if we needed to. I think is use that templating approach of we've got this pattern that works in this existing repo. Let's generalize that into a template that will reuse elsewhere for sure.
Cool. I like that. So just to quickly move on, and we don't have to cover this one in as much detail, you also talked about a different sort of footgun that you built some libraries and scalable approaches around. So yeah, I wonder if you could tell us a bit about that.
Yeah, the other one we were looking at here was it turns out that unpacking uh, compressed archives is not just an unzip and move on or an untar and move on, but that there is security risk, there are security attacks associated with those formats that when you're unpacking archives from untrusted sources, you do need to be cautious of. Like there's the old school zip bombs, there's more recently zip slip, there's there's ways that attackers can manipulate, like using symlinks and various other methods to use processing of untrusted zip files or untrusted tarballs against an environment. Um, what we've found is that this is one kind of thing that a number of our products do. They all do it in different ways, and we have come across one or two issues where we have had some exposure to those types of attacks. So we're earlier in the piece here, but what we're working on doing is building essentially a shared extraction library, a shared decompression library that addresses those types of security attacks in a secure way, and then can be reused across the product. So this is something that we're describing that kind of program level capacity where we're talking about where we've identified this product specific concern, but we're now addressing it at the program level where we write the code, we build this module that would be provided across the portfolio to be used and to avoid kind of continuing to experience or continuing to have to re-implement this capability across products as they need this feature. So kind of similar approach to rollout here, as I described earlier, where you start by kind of trying to slice it down to a smaller thing that you build first and prove out and then expand over time. Relatively early stages, but that is an example of something else we're doing here.
Cool. I like that a lot. So yeah, moving on and just starting to wrap things up, I was curious if you have any final messages or lessons learned or just anything in general you'd like to leave people with.
Yeah, sure. Well, I really appreciate the time. It's been good to chat.
Oh, thanks for your time.
I'm going to go big picture with this one. Like I feel like we've been down in the weeds a little, kind of talking about product security. I look at the world these look at the state of the world these days. I look at the state of the industry, the state of the economy, and I don't know. I'm a firm believer in, as a security person, bringing empathy to as much of my security practice as I can. Like I am, my approach to security is not that, we are not a team that says no for the most part. We generally try to say yes, or maybe let's figure this out together. Try to understand that security is kind of part of the business, it's part of society at large. Yes, we have our own goals, but we are one of many conflicting priorities that the business, the engineering teams, people out there in society are dealing with. So, yeah, for me, kind of, I just interactions with security should be something that people can come to us in a manner and have us respond to them in an empathetic fashion. Like that's one of my big picture things that I keep on coming back to. I have an interesting
Mhm.
kind of other take on this too. So two things maybe you should know about me and my approach to security. One is, having grown up in New Zealand, there's a fairly common kind of cultural approach or saying down there, which is, "She'll be right, mate." Like it's kind of a common refrain that gets pulled out in various situations, with the general approach being that, whatever situation you're in, things are probably going to work out. Like I guess another way of looking at that is this too shall pass, or there's various other things to that, things that describe that. My upbringing as a Kiwi, and then 11 years ago, our first son was born, and I spent, sorry, our
Mm.
first child was born, and he was born very premature. So I spent 4 months going to the NICU and kind of living this life of like intensive medical care for somebody who I loved. And
Oh, wow.
I will never approach a security incident the same way again. Like going through life and kind of um, experiencing events that kind of help you, yeah, put a little bit of a different lens on what we consider to be important and don't. Yeah, it's life is precious, I guess. So it's easy to get. I guess where am I going? It's easy to get hung up on trying to achieve whatever your security controls are, security goals are. They are important, but yeah, always kind of empathy and keeping the big thing, and the little thing the little thing, right? It's, yeah, big picture stuff, but it's important, I think, for people to hear.
Yeah, totally agree. Empathy is huge, and this too shall pass. I like it.
Yeah.
But yeah, Jamie, thank you so much for your time. Where can people find you online or connect with you later?
Yeah. Oh man, I blog very occasionally at chair6.net. There's kind of some security related writings from over the years there. I still I contend that Strava is the best social network. Like, there's no politics, there's very little business, and it's just good motivation to get outside and do something. So that's my social network of choice. But I'm also Finnigar on Twitter, Blue Sky, GitHub is me. So yeah, I'm there if you Google me, I guess.
Cool. Well, yeah, thank you so much for your time. I learned a lot, and it was a fun chat. And yeah, thank you everyone watching for your time. Feel free to, like, subscribe. I don't know, check this out for future interviews. And yeah, have a wonderful rest of your day.